hit record. Okay, and I will share slides. All right. So this is the presentation I did at IAW called Let's Carry On Together. I did the presentation, I did the card at IAW with instructions on how to pull the software and get ready so you could run alongside the demo if you so chose. No one did, which was a little disappointing, but the repos here, it's the Kerry PI repo, the Web of Trust. It's a lot of all of the networking and asynchronous IO is based on coroutines in a library Sam Smith created called HEO. Right now, what I'll be running today requires Python 3.9.7, but we're now up to 3.10.3. And these are the instructions if you wanted to follow along. Git clone the repo itself, check out the feature IAW branch, and then just run a pip install of the requirements file to get all of the dependencies. So most of actually everything that we'll be showing today starts with the Kerry command line interface that we call CLI. It has commands and subcommands, much like if you're familiar with Kubernetes kubectl command line. So that, for example, if you were doing something with verifiable credentials, you would start KLI VC, and then there would be a subcommand following after the VC, for example, issue or revoke.
Okay.
And then we do have Docker containers that have all of the code pushed and configured ready to run. So you can pull one of those and do a Docker run running a subshell, and you can use the KLI to perform tasks. So the basic structure for the commands in the KLI, the groups that we have, pardon me, the agent group for running our cloud agent, which is also run in the distributable desktop application we're building using PyInstaller and Electron to bundle Kerry PI behind a web UI. That web UI uses the agent. If you want to perform some delegation commands, there's a couple of subcommands under delegate. If you want to create a distributed multi-sig identifier, you would use the multi-sig commands. And then the verifiable credentials I mentioned. The wallet commands are simply for listing the contents of your wallet. And by wallet, I mean verifiable credential wallet. And then to start witnesses or watchers, you would use the watcher group with subcommands like start and demo.
So Phil, all these, well, everything on this page, is there documentation as to what exactly an agent means? Like, do you have the terminology somewhere?
No, no, there isn't. But that would be a good thing to add to getting started, I guess.
Yeah, absolutely.
Yeah.
Yeah, so I mean, we could certainly create like a vocabulary dictionary and then maybe a one-liner description of what each like run cloud agent does, what delegation means.
Yeah, that'd be great.
Where would I find that
info? Look at the command line. If you run just help from the top level, it does list.
Can you share the screen?
Oh, I'm sharing just the spreadsheet. I mean, just the presentation on it. Let me share that whole desktop. There we go. Okay, can you see the command line now?
Yeah.
Okay, so if you run KLI help, you get a list of the commands and subcommands, and they do have one-liners. Not all of them are accurate at this moment, but that's something we
doesn't matter as long as it'll be a placeholder.
Yeah.
In the worst case scenario. Okay.
Okay, so for key management, the top level commands, the very first thing you almost always do is do an init, which initializes both your data store and your encrypted key store. Inset for creating a single sig identifier. Technically, you can create multi-sig identifiers with that as well, but they're not all that interesting because all the keys are stored in the same key store. The different key events that you can create, an interaction event or a rotation event, are handled with the next two commands, interact and rotate, and they each take parameters. Rotation, for example, specifying your signing thresholds, number of keys, rotating in and out witnesses, all the things that you can do when rotating. and purge, just delete your key store. So then the miscellaneous commands, querying witnesses for a kel, sending your kel to another agent. We don't use that very much anymore because we use OOBIs to accomplish that now. Signing, pardon me. You can just sign arbitrary data and it will return the signatures based on the identifier that you used, and I'll be demoing that in a little bit. Verifying those signatures. And if you're just exchanging signed data with someone via an email, this will accomplish that for you. Then listing the identifiers that you're creating and giving a status of a single identifier. So it's important to point out that with the most recent updates to Kerry PI, we now have first-class support. We now have first-class support for multiple local identifiers. So that's why we have the list command. So you can run init once, create a single data store and key store, and then run incept as many times as you want to create other identifiers. And you use those for like peer-to-peer communications and things like that so that you can't be correlated. All right. So each of the three top level runnable components, an agent, a witness, or a watcher, each have various startup commands. You have the bootstrap command to start an empty agent or to run a single agent against one that's already been started. You can run start. And then both for witnesses and for agents, we have these demo commands, which we make heavy use of for local testing. So for example, under the witness, this starts up 3 well-known witnesses. And by well-known, I mean, we use salts to initialize their key stores so that you can predict what identifiers will be created for each of those. And again, that's not anything you'd want to do in a production environment, but for running tests, and we'll be using particularly the demo witness command later on to start witnesses so that other commands that need witnesses know where to find them. And then we have similar commands for watchers. Part of the demo today is running through a series of scripts that we've created in the demo directory located in Kerry PI scripts demo. And the most basic one is just demo script, which starts off and runs all the really basic commands. Demo witness script runs through some of the same commands, but requiring witnesses to be running. And then we get into the more interesting stuff: delegation, multi-sig, multi-sig delegation, multi-sig delegation, where both parties of the delegation are a multi-sig identifier, and then credential issuance and multi-sig issuance. During the demo at IIW, we did not get to these. We only got this far, and in an hour, I'm not sure we'll even get to these, but we will see. Oh, I forgot to point out all of the sample JSON files are also located in Kerry PI tests app CLI, which contains when you do a KLI incept command, it takes a file for all the properties that you want to pass in for the creation of that identifier. For example, how many signature or how many public keys to create, what's your signing thresholds, what witnesses to use, whether it's transferable or not, et cetera, et cetera. And I'll show these as we go through them today. And then finally, another big enhancement in this most recent round of changes to Kerry PI was the addition of out-of-band introductions, or OOBIs, and they are files. These are startup files that contain bootstrap OOBIs. So for example, when we use the demo command for witnesses, like I said, they're well-known identifiers. They also start up on well-known ports, and they publish those ports via a series of OOBIs. This is a configuration file that any other agent can run and know exactly how to contact those witnesses. And this is the configuration file for those witnesses. So we'll get to those in a minute. So that's it for the, pardon me, that's it for the presentation. There's not slides anyway. There's not that much in terms of slides. Here is just enough to get us kick-started. So now we'll go over to our first script today. One thing I didn't point out, but I wanted to make clear, because we have the KLI, which you can do everything you need to do with Kerry in Kerry PI with the KLI on a command line, and that's for running in a mode where you're not always on the internet. But as I pointed out, also we have an agent that can run that could be a continuous or persistent connection to the internet. So a cloud agent, for example. And in that case, the cloud agent exposes a series of REST APIs that perform the exact same functionality as all the KLI things that we'll be going through today. And in the demo scripts that you see here, for every script starting with delegate, there is a sister script next to it, -agent, that is the exact same command, but with a series of curl posts. I'm sorry, the exact same functionality, but executed as a series of curl posts against an agent or puts. And I'll show when we launch the agent, we also expose a Swagger UI, which allows you to, if you wanted to, execute commands against it. And I'll show that towards the end. So let's start with a basic demo script. And let's see, how do I zoom in? There you go. I'll zoom in here a little bit. Is that legible for you?
Yeah, much better now. Thanks.
Yes. Okay. So the very first thing this does is create a key store with the init. Currently, KERI now supports the ability to create a key store and data store, for that matter, with a passcode. And when you do that, it becomes an encryption key. Well, it gets stretched into an encryption key that is used for encrypting the key store so that no one else can gain access to your private keys. That passcode is never stored anywhere within Kerry PI or the agent. So it has to be protected by the user, because otherwise you can't get access to your keys.
Sorry, Phil, give me one sec. There's just something going on here. 1 sec. Sorry. Sorry about that.
No worries.
Okay.
Okay, so for all of the commands that we're going to be running today, we just pass in the flag no passcode, so the key store isn't encrypted, and that's just to make things easier, so we're not passing passcodes around to every other command. But anywhere where you run a subsequent command after init, you can pass in ---- passcode, and it'll unlock the key store if it's indeed locked. So the very first thing that this does is create a database and key store. As you can see from the comments, the name of the database, the name of this instance that you're creating is called test, and that is used to create the directory structure for the databases that support both the wallet and the key store. Those databases can go in one of three places. When configured properly, you can create a database and key store in /temp, which obviously is used just for testing, and we use that heavily when running all of our unit tests. If you have a directory called /user local var KERI, and the current user has write access to that directory, it'll create all the databases under there, and then they're prefixed with the name that you give it here. If you don't have that directory, the last place that Kerry PI attempts to create the data stores is in your home directory .kerry, and then it would begin with test for this one after that. So those are the three places you want to go look for your key stores. So after it creates the key store, we create a non-transferable.
Sorry, can you, when you,
Yep.
Would you define which one of those three places to look for here?
No,
or is it just the way you're installed, you're set up?
That's correct. It's the way your system is set up. There, we don't support the creation of temporary from the command line. We could add it as a flag, I guess, but we don't currently support that. So this will, from the command line, this will create the key store in either /user local var KERI if it exists and you have write access to it, or under .KERI in your own directory if you don't have that other one. Yeah, we could definitely add the ability to create in temp from here, but that would just be another flag. So the first thing we create is a non-transferable identifier. After you give the name of the data store, you give a local human readable alias to this identifier. And as I mentioned, you can create multiple identifiers. So you would give them per a single key store. So you can give them whatever aliases you want so that you can remember what you're using that particular identifier for. So this is creating a non-transferable identifier, and we'll start by opening that. So he is transferable is false, obviously, and a transferable identifier means that you, or a non-transferable identifier in this case, means that you cannot perform any rotations against this. You can't transfer to another set of keys. That's why it's called non-transferable. So these are basically throwaway identifiers. You use them, for example, witnesses use non-transferable identifiers because they themselves won't ever have any witnesses. They don't perform rotations at all. If you feel like a witness has been compromised, you just destroy that witness and start over with a brand new one and rotate it out of your key store, out of your identifier that's using that witness. So because it has no witnesses, toad is the witness threshold. I have no idea why it's called toad. That's a Samism. So we have a 0 witness threshold because we have no witnesses. The I count is the number of signing keys to create. The N count is the number of next keys. If you're familiar with KERI pre-rotation, this is the next keys to create. And then these are the signing thresholds. I for current signing threshold, N for next signing threshold. And these have to be 1 for transferable identifiers across the board because they only support single sig. All right, so after we do that, we try and rotate this identifier and we capture the fact that we should get an error because you can't rotate a non-transferable identifier. Then we move on and we create a transferable identifier. I'll open that file. The only difference between this and the previous one, because we're not going to do witnesses quite yet, is that we have the flag transferable equals true. And you'll notice when we create those two identifiers that they have different prefixes on the identifier, which, because all cryptographic material is encoded in qualified base 64, we have a derivation code on the beginning that indicates one is a non-transferable and the other is a Blake 3 hash of a transferable identifier. It's B versus E. So after we create the transferable identifier, we then try and perform a rotation event, which should work because this is transferable. We then rotate and we anchor data into it. And in this case, the anchor is just a simple, this is a standard anchor, for example, for performing a delegation or anchoring a transaction event log event into this. And by anchoring, we mean making a cryptographic commitment to whatever this data points to. So for example, in delegation, if I were being a delegator and someone requested a rotation event, I would create an anchor similar to this. This is okay. This wouldn't be 0, but okay, this is the prefix that I'm approving, the AID, sorry, that I'm approving. This is the sequence number of the event that I'm approving, and this is a digest of that event. Same thing if you were anchoring a issuance event from a public transaction event log, it would look exactly like this.
And the sequence is for what?
So remember, key event log, key events are a sequence of events. Yeah. So you do the inception is 0, rotation is 1, et cetera, et cetera. So that's an index into the key event log that this event represents.
Okay.
We perform an interaction event, which anchors the exact same data, just for testing purposes, obviously. Then we perform a rotation event that gives us 3 keys with a signing threshold of 2, and then another rotation doing the same thing, because remember, this is an interesting thing to remember about KERI. Because you do pre-rotation, you need at least 2 rotations to get to a new number of next keys. So when we first created these, if you remember, I had a next key of 1. So after this rotation event, we will only have 1 key because that's what we previously committed to, but now we prepare ourselves to have 3 keys if we perform another rotation event. These are the sign and verify commands that I mentioned earlier. So we sign the data, just signing. Again, you can have any arbitrary data. You can specify the data on the command line if you want, or if you use the @ sign here, you can specify a file to sign. And then we take the 3 signatures and pass them into the verify command against the same data using the same identifier that signed them, testing with the same identifier that signed them. And we get whether they're verified or verifiable or not. And then in this last one, I just messed with the signed data and to verify it, to generate an error on verification. And the last bit here is just testing establishment only. And that's just another flag that you can pass in when creating an identifier. EST only is true, and that means you can only perform establishment events, which are incept or rotate events. And that's a security enhancement to an identifier so that you can't ever expose your public key repeatedly by doing interactions, which just sign and anchor data, but they never rotate keys. And repeated use of a public key weakens it because it exposes it and allows people an opportunity to try and work against it and break it. So with establishment only, every time you do anything, issue a credential, approve a delegation, etc., you're getting a new set of you're getting a new set of keys. So the keys are only exposed once when they're first created.
Okay.
All right, so let's go run that. How are we doing here for visibility? Need me to zoom in a little bit?
A little bit bigger would be good.
How's that?
Okay. Yeah.
All right, let me give myself a little space. Oops. All right, so the first thing we'll do is, so the very first thing we always do is delete our key store. Because I'm developing Kerry PI and working with it every day, I repeatedly am deleting my key store. So if you're going to ever do anything with Kerry, you get used to running this command because you're creating new key stores for testing and you don't want to keep the old data around. So you'll just see me do that repeatedly throughout the demo today. So we'll run scripts, demo, script.sh, see if I'm in good shape.
This is a stupid question. So when it's the key stores are stored in that folder, right? var Kerry, what format is it in?
Those are LMDB databases.
LMDB?
LMDB, yeah. It's a read-only, or not read-only, it's a lightning fast key value store, supposedly the fastest database on the planet, according to Sam, according to them as well. That's what they claim.
Okay.
All right, so we'll just quickly go through the different commands that I already talked through in the script. We created the key store in the database, and we created a credential store as well. And you can see I have write access to user local var Kerry. So under key store, created a test, under database test, and reg for the registry for the key credential store, it created test. This is the non-transferable identifier that we created. It has a derivation code of B at the beginning of it. And interestingly enough, the public key is also the identifier. Here's the error that we generated because we attempted to rotate a non-transferable identifier. That's a good error. And then next we created the transferable identifier, and it starts with E. So you know that that's a transferable identifier just by looking at it. And the public key is different because this public key, this identifier is generated as a hash of the inception event. So that's how we generate identifiers for the transferable identifiers. And then using the same one, we did the first rotation. We did a second rotation. We anchored data in here somewhere, which I'll take a look at with the status command next. And then we started doing that. We did an interaction event, and then we did the rotation to get 3 sets of keys. Okay, that was the second rotation event with the 3 on it. And then here are the 3 signatures on that anchor data. And those are the same that are in the script because when setting up the script, I copy and pasted them in there. 1, 2, and 3 is valid, but signature 3 is not valid. Now, interestingly enough, you see that with only passing in the signature, the code knew that they were 1, 2, and 3. And that's because when using a multi-sig identifier, when you sign something with it, you create what's called indexed signatures. So the derivation code contains not only a code to tell you that it is a signature, but also it is an index signature so that you can see AA, AB, and AC. That's hex for 0, 1, and 2. So we know that they correspond to the first public key versus the second public key versus the third public key.
Cool. So how come it says signature 3 is valid and then error signature is invalid?
Because this is the one in the shell script that let's open that script, demo script. I ran this one with a messed up signature. So I took signature 3 and I changed the end of it. So it's an invalid.
Oh, okay.
Just to show it failing.
Right.
Yep. I should change the anchor data because changing the signatures not as interesting. But anyway, one of the commands that I talked about at the beginning that's very useful is the CLI status command. And we'll take a look at the test key store and the alias of trans. And you can see that it's at sequence number 5 because we performed an interaction in several rotation events. We're not using any witnesses, so this is blank, and these are our 3 public keys. But more interesting with the status command is the use of the verbose flag, which gives you the full key event log. So now you're getting into the real guts of KERI here. You can see exactly, oh, oops, that's not what I want to do. You can see, well, first we specifically list the witnesses when you run verbose, which he doesn't have any, but now you can see each of the commands. So here's your inception command. Because we use self-addressing identifiers for all KERI events, his digest is the same as his inception, is the same as his identifier, because this is an inception event. And here's his key, and here's his cryptographic commitment to his next key, his pre-rotated key. Now we perform a rotation, so you could run Blake 3 against this and prove that it matched up with the pre-rotated next key to verify that this is the correct rotation event. And his identifier, of course, doesn't change. That's the whole power of KERI for key management. But he has a new self-addressing identifier because this is the hash of this event. Okay, then we move on. And this is where we anchor the data, and this is what an anchor looks like. So it's simply in the A field, which is an array of any data that you want to anchor in here. And this is that anchor file that I showed you earlier. Here's an interaction event. You see there's nothing specifying any key changes here because you don't change keys with interaction events. You're just anchoring data. And here we've anchored the same amount of data. You notice also every event but the inception event has a P, and that's an anchor to the previous, thus making it a blockchain, an anchor to the previous event. Okay, and then finally, we performed the rotation to give us 3 next keys. But as I said, because we had already committed to 1 key, when we did that 3, we got 3 next keys, but only 1 public key. So we had to perform a second rotation to get 3 public keys. And this KT here is the signing threshold for so you need at least 2 signatures to make anything valid for this identifier in this current state. All right, so that's the first intro script. Any questions about that?
I don't know enough to ask questions, no. So I know from reading some of the specs that all those like VT, whatever, the field names are all defined in the spec, right?
Yes, they are. Absolutely.
Okay.
Yeah, it's funny. I mean, I'm at the point now where I look at mine and my head just reads them out loud to me.
Yeah, I'm not there yet.
Yeah, it takes a while. And Sam's changed them repeatedly. So keep going.
Great.
Like a K here B, all the B's, they used to be W's because they used to be witnesses, but we changed them to backers instead of witnesses. So now they're all BT, BR, and BA. But
is a backer a witness?
Yes.
Or it's a different role?
You can have either a ledger backer or a witness backer. That's why we changed the name. And a witness backer would be using standard KERI infrastructure for witnesses, and then you can have as many as you want. But if you have a ledger backer, you're anchored to just 1 ledger, and that ledger serves the role of both witnesses and technically watchers.
So a ledger is greater than a ledger contains witnesses.
Ledger serves the role of a witness if you have a need for distributed ledger technology in your infrastructure. If you're relying on cryptocurrency or the economics of a token or whatever, then you can use that and trust if you want to put trust in the anchoring of your events in the ledger instead of getting receipts from witnesses, you can do that. It's not better, it's just different. It's just a different way to provide that layer of security. So the next thing I'm going to do here down in the lower window is to launch.
So as a sidebar, has there been discussion about using tokens?
Not for us, no, but
like crypto,
at IAW last week, there was a really, really interesting session that Richard Esplin from Evernym, now Avast, held, asking why KERI versus why a ledger. And the whole point of it for him was that it was a great session. He held it on Monday and none of us were able to attend. So then he re-held it again on Tuesday, or I'm sorry, on Tuesday, it's the first day. On Tuesday, then he held it again on Wednesday after talking to us Tuesday night at dinner. He held it again on Wednesday so Sam and myself and Kevin could participate. Pardon me. And the whole point of it for him was, okay, if I'm instructing clients who want to build a SSI infrastructure, do I tell them use KERI? Do I tell them use a ledger? What do I tell them? And it was great to clear up a lot of misconceptions, because people think, oh, you can't use a ledger with KERI. No, that's not true. You don't have to use a ledger with KERI. We don't think it's needed at all. But as what Sam pointed out during the talk is, if you already have an investment in ledger infrastructure for other reasons, you can then leverage that ledger as an additional trust threshold or security threshold for your identifiers instead of using witnesses. So no, we're not. I mean, the VLEI won't be using anything to do with cryptocurrencies or tokens. But if well, for example, a lot of people are using SSI systems based on Indy networks right now. If you want to transition to using KERI, you could do that by anchoring your KERI identifiers in your Indy ledger. And then the neat thing about it is you could then transfer them off of the ledger and have non-ledger based identifiers. So that's what's great about KERI. It's portable. You can be anchored to any one ledger at a time, or you could move it to a different ledger, or you could move it to using just witnesses, all with the same identifier, by just doing rotation events and changing your anchor, your backers here.
But could you also do could you be anchored, let's say, to multiple indies or Ethereum?
You only anchor to one at a time, because that's the source of truth for that identifier at that given point in time. You can then rotate to a different one, but you can't have two ledgers at the same time.
So when people, maybe I misunderstood. So I understood that, okay, one of the problems of blockchain is that you have to be committed to all use the same network, which is not practical. That's right. Unless you're running an ICO scan. So I understand KERI is digital ledger technology agnostic, and that you could use it could interoperate with existing ledgers like Aries or Indy, whatever it's called. But it's only that one network. You couldn't connect Ethereum and Indy to the KERI ledger.
Correct. Yeah, KERI couldn't be used as a technology to bridge between networks. That's not what it's designed for. But you could use it to move a single identifier across networks if you wanted.
Oh, okay.
All right.
Yep.
Okay, so moving on. The next command I'm running, again, we do the RM minus RF and then KLI witness demo. This starts these three witnesses and we give them aliases of Wan, Will, and Wes. And these are the three identifiers that I now know by heart because I start them 100 times every day. And they're started with a given salt for each one so that the identifier is predictable. Now we get to OOBIs. This is the really interesting part. So OOBIs are out-of-band introductions, allow people to discover full key event logs, witness key event logs, and service endpoints for any other identifier. And you can see here, they are simply URLs. So in these cases, this is an OOBI. We know that because it starts with /OOBI in the path. This is the identifier about whom this OOBI is referencing. And this is the role that this particular OOBI is playing. So in this case, this is a controller OOBI for this witness. We'll take a look at two configuration files. So this is new with the most recent version of Kerry PI. We have the ability to specify configuration files. Previously, when we did our first pilot for Glyph with this, we were hard coding IP addresses all over the place because we didn't have a discovery mechanism, but we now have a discovery mechanism that's using OOBIs. So when you start any agent who's going to run with persistent connection, like our witnesses, or if you run agents, you can specify a curls field in their configuration file that specifies endpoints that he will be exposing. So in this case, the scheme, he's exposing a TCP endpoint on this port, localhost, and an HTTP endpoint on this port on localhost. When he generates OOBIs, he can generate OOBIs for either of these endpoints because he's been told through this configuration file that that's who he's listening on. So when he generates an OOBI, for example, for a controller, so a controller is basically saying, this is where you can contact me directly, not through a witness, but just contact me directly. Pardon me. He would generate an OOBI that looks like this. Okay, we're already scrolled over. This is the little window of the two of us was blocking it. So it's again, it's the location to contact this OOBI, which is of course the same as his HTTP endpoint, what the identifier, who the identifier is, and what role this OOBI is playing. Now, interestingly, when you look at the command line, we ran 6 OOBI resolutions, little green checkbox said they all worked. And that's because now when we start this based on the configuration file, not only does each witness expose his endpoints this way, but he also resolves the other 2 witnesses' OOBIs. So at startup, he exposes this, then he reaches out to this witness on this at this address, and this witness returns a reply event, which contains his key event log, which is very simple because he's a non-transferable identifier, and a reply message containing his endpoint information that he has had configured via this configuration file. So now all the witnesses are communicating with each other and establishing how they could connect with each other if they need to. And also if someone is, let's say, as we will demo in a minute, someone is using all 3 of these witnesses. When someone asks a witness for an OOBI for an identifier that he's a witness for, he can say, oh, well, he's also he also has these other 2 witnesses, and here's their connection information. Doesn't have to do that, but he can because we've configured him to resolve the other witnesses. And then Will and Wes's configuration file is the same, except of course he's referencing the other 2 identifiers.
Right.
So now we'll look at demo script. Witness. Again, this is, we initialize the key store with no passcode. We do an OOBI resolution against each of the 3 witnesses. Those OOBIs should look familiar because the ones I just showed you in the configuration file. So now this new data store now has the information for each of these 3 witnesses. So he's configured to be able to use them as witnesses if he wants. However, if we were running an agent, we would probably create a configuration file like this one. If, for example, we were, which we will be for the VLEI system, packaging up an agent that has pre-configured witnesses that we're anticipating everyone will use. And then we create a configuration file, which gives them OOBIs to those witnesses. So when they start up, they automatically initialize those and bring all the data over they need so they can communicate with those witnesses. But you can do it with the command line here, KLI OOBI resolve. So that's what we do for this. So then we do an inception event with the trans wits sample, and then we create an inquisitor, and then we do a status of this with his witnesses. We perform a rotation, witness cut, so that removes this guy from his set of witnesses. This is rotating a witness out because I don't want to use him anymore. And then we do a status again to see that he's gone, that he's down to 2 witnesses. This is fixed. I fixed this. And then we do a KLI rotate with a witness add. So we add that witness back in, and then we do another status to see that he has that witness back in as part of his witness set.
And what happens if you never added that back in? Does something tell you you should have 3 witnesses?
No,
or
you don't
okay
need 3.
It's you don't have to.
You don't have to. It's just saying that you now have 2. And when you rotate this out, it will also change your witness threshold. I think, let's take a look at this guy. Yeah, so you can see when we create him, he's created as transferable with these 3 witnesses, and he has a witness threshold of 2. So that means you only need receipts from any 2 of these for it to be considered.
Okay, that's what I was wondering about.
Now, if this were,
so if you put that to 3 and you removed, or you cut that one,
you'd get an error.
Oh, you get an error.
Yeah,
okay.
It would tell you that
you can't cut them.
You can't. Yeah, it would say your witness threshold of 2 is your witness threshold of 3 can't be satisfied because you only have 2 witnesses. So
you're supposed to create a new one, add a new one, and then cut one?
You can change the threshold on the command line. So you do something like code 2, and then that would make it valid.
But wasn't there a reason why it was 3 in the first place?
It's all your own identifier, and you're controlling your identifier. So it's up to you to determine what security constraints you want for that identifier. So yeah, okay. Sure, you probably created it with 3, but if you're just saying, okay, you know what, now I only need 2, or I'm only going to have 2 temporarily because I need to go find a new witness, you can do this. Again, not the most practical example, but just showing how cuts and adds work.
Yeah.
Does that make sense?
Yeah. Yeah.
All right, cool. So let's run this script and we can watch it go through its process. Yes. Oh. All right, creating the key store. This is the OOBI resolution so that this guy now knows how to contact those OOBIs. And you can see he's going through all the different steps, and we'll go step by step through this. Page up. So this is where he initialized his, or he resolved his 3 OOBIs with the OOBI resolve command. And you can see part of the incept command also takes your identifier and propagates it to your 3 witnesses, however many n number of witnesses, waits for receipts from those witnesses, then collects all the receipts and passes them out to all the other witnesses. So he propagates the receipts from everybody to every witness. So every witness has a fully receipted key event log for him. And that's what waiting for witness receipts is here. And that all happens as part of the incept command. Then we did the status command. So this is elf, is elf is our new identifier. And you can see that he has a signing threshold of 2, but he got all 3 receipts. What did I just do? And then as we go on, you can see this is where he cut that 1 witness. So he's now down to 2. And this is where he added him back in. He's now back up to 3. So we'll do a quick test. Fingers know I made a mistake. My brain didn't. Yes, I call this guy transfer. What did I type wrong? Last name. Witness test trans wits. Okay, so here's the key event log. For all those things that we just did. This is the inception event, and in an inception event, you just specify the B field with the backers you're going to use for this, and the BT is your backer threshold. So that's the toad of 2 that we saw. Here's the rotation event that did a BR or backer remove. So this cut that witness from the list. And then this is the second rotation event that did a BA. So it added that backer back into the list. And when we did the verbose, you can see that he's now back up to those 3 witnesses. All right, so that's using witnesses with an identifier. Again, I don't think, did I show the? Yeah, I showed this. Yeah. So you just specify your witnesses in the wits configuration, in the wits field of the configuration file when creating an identifier. And that's in the demo script. When we did the incept, we specified that file, transwit sample. And I used to do a query in this. That's why we're creating this guy Inquisitor here, but we don't do anything with him. But we can take a look at the KLI list. Still work it, and you can see I have 2 aliases, Inquisitor and transwit. So I have 2 identifiers in this 1 key store. And that's who they are. And then from there, I could do a status to see what each one looks like. All right, we got 15 minutes left. We're probably only going to get through delegation because I want to show you the agent real quickly. Okay, so we'll go over here. We'll start closing some windows. All right, so let's go over delegation. So with delegation, we're going to create 2 identifiers. One is the delegate and the other is the delegator. So we create both key stores. Then we run an incept command for the delegator using this configuration file. He should look familiar. This is just like the transferable guy we just created, all the same features. Oh, yes. Here's where we're specifying a salt for each of these so that we know what their identifier will be when we generate them. And then we do an incept command for him. I just said that. And then the delegate key store is resolving the OOBI for the delegator. Now this OOBI is different. This OOBI is a witness OOBI. So because, as you saw in the configuration file, I'm using these 3 witnesses, he can generate an OOBI which tells anyone interested how to contact him through his witness. So it starts with OOBI just like the other. It starts with the AID or the identifier for whom this OOBI is about. And then the role in this case is witness. And then it specifies the identifier of the witness. All right. So let's get started. Yeah, so I guess I have to run this. Kill and restart because we want to clean data store. Actually, I don't technically for this one, I don't have to, but I'd like to do that. You hear my grandson crying in the background. All right. Oh, sorry. One thing I forgot to point out is this command here when you incept. Oh, let's open him. So we'll look at delegate.delegate.json. So the only difference with him from all of the others that we've done before is that he specifies a del pre. So he's saying any key event that I do, any key management event that I do, an inception or rotation needs to be approved via an anchor by this identifier. And the anchors are what we saw earlier. You do a rotation event or an interaction event, and you put that data in there. And by signing that key event and anchoring it to your key event log, you're making a cryptographic commitment approving this, whatever event he's requesting. And we'll take a look at that data as soon as this is done. So he's only using one witness just because I'm lazy. So he will then wait because he has a delegator. He'll wait to finish until a delegator approves him. This command is actually reentrant. So if you control C it, go away, call your guy, say, hey, I just sent you a delegation event. Can you approve it? He approves it. You can come back and rerun it and it'll finish the event, propagate the receipts to the witnesses, etc. But in the meantime, we'll just leave him running and we'll go to another window and the delegate.
And how does the delegate, how does that person know that they're waiting on it?
How does
aside from you saying get on the,
yeah,
get on there and approve it, is there some messaging?
Yes. So this incept command will actually notice that he has a delegator listed in here, and he will send his key event for his inception event to the OOBI that he resolved, to the endpoint that he found from his OOBI resolution here. And the delegator or any identifier, when they receive a key event and they process it, and they're listed as the delegator, it's a trigger that they have something to do. And that's what this delegate confirm command is. He wakes up, checks his mailbox, and in his mailbox, he finds this event, notices that he's listed as the delegator. And so then he will ask, you'll see on the command line, he'll ask, hey, so-and-so wants you to be their delegate, and you can either approve it or deny it. I guess reject is the better word. So did I do this yet? I'm pretty sure. Can't hurt. All right, so we're going to run this. He's resolving the OOBIs for the witnesses, and you can see that he resolved the delegator's OOBI right here, and then he says waiting for delegation approval. So he's just sitting here waiting, scanning for for this person to approve his event. So I'll just copy and paste this. So he wakes up, he discovers the inception event. So he says a delegation inception request. Wow. A delegation inception request from this identifier, accept or deny. I will accept it. He signs the event. He propagates his own event to his witnesses and then sends the fully receipted event back to the delegator, to the delegatee, who then says, okay, I am now an approved event and I'm going to get my witness receipts. And here is my new identifier. We'll look at two different status commands. So we'll do KLI status. It's delegate. It is. So you can see because he's a delegated identifier, the status command now prints out this bit of information. Here's my delegator and the fact that he's anchored. And this is important because if I were to control C and do a status, I could come back in 3 days later and do a status that doesn't say, shoot, he hasn't been anchored yet. I need to get on the phone and bug him or whatever, or run the incept command again and see if the anchor is out there for me to process. And then he's done his witnesses. So if we look at a verbose here, this is his inception event. Because it's a delegated identifier, it's a different tag, or sorry, different type for the inception event, a DIP instead of an ICP. And the only other difference here is the last field is a DI, which is the delegating identifier, and that is the delegator. So then anyone processing this will know that this is a delegated identifier, and any event that he processes has to be approved by this guy for it to be a valid event. Now, notice here, his identifier is EY7 because it's an inception event. The I said that backwards. This is the identifier. Because he's an exception event, the set of this is the same. So these are the two, and he is at sequence number 0. So now if we take a look at the delegator, you can see his rotation event here. This is the approval, and that EY7 is the identifier, as well as the sed or digest of the event that he approved, and he has anchored that data, thus approving the delegation request from the other guy. All right, so all that makes sense.
Maybe one day, yeah, that's what I'm shooting for. That's what I'm aspiring.
Yes, there's a lot. There's a lot here. All right, we have 8 minutes. I will try and get through multi-sig. Actually, you know what? No, I'm
Don't rush on my account. I mean, I understand you're on vacation, but don't worry about my time.
Yeah, no, I have another meeting I have to get to.
Oh,
Actually,
okay.
not only
So
am I
much for visiting the family.
Yeah, exactly. Yeah, but not only that, but I'm out here buying a house because we're moving out here. So all that hassle as well as work. It's been very, very busy week. All right, so let me show you the agent really quickly. So here we start. Actually, I don't need the witnesses, but anyway. So we will run KLI. So I'm running KLI agent demo. Just like the demo command down here, he starts, except in this case, he starts 4 well-known agents, and that's because I needed to test multi-sig delegation with 2 participants in the delegator and 2 participants in the delegatee. Delegation coordination. I start him with a, that's not gonna work. Well, that's fine. I started him with a configuration file that tells him where these 3 witnesses are, and he starts 4 agents on these well-known ports, again with, actually he doesn't have well-known salts because you do those via the crawl commands. So once you start those agents, let's see, here we go. You get on each of those ports a Swagger UI, which contains the available API calls for the agent depending on his state. Every agent initially starts off in a locked state. So think of remember when we did the KLI init commands and created the data store, that data store is now encrypted and locked if you gave it a passcode. So in this case, we don't have any data stores yet. So you can start an agent with no data stores around, and that's when you end up in this state. So in order, our passcode requirement for creating an encrypted key store is a 22-character passcode. We give you just a little helper function. This isn't really part of KERI, but we give you a little helper function for, my grandson is really unhappy. For just generating random passcodes. If you need that, you can also use 1Pass or whatever to create them and then store them in 1Pass. So now, just like KLI init that creates a key store, we have a post to /boot, which will create a key store for you. You call it, let's try it out. Let's not type into the sample. I did that during the demo too. Agent 0, let's spell agent right. And give it the passcode that you saved and execute. And you can see that agent 0, agent and key store created. And he resolved a whole bunch of OOBIs. That's part of the configuration file. Oh, I guess I do have it running good. So one thing to note about here is several of the OOBIs are actually data OOBIs, and we can also use OOBIs to resolve things like credential schema. So that's a whole separate topic. So now that we've created the key store, the next step is to unlock it. And so this is like, so we ran this demo at IIW after doing our demo hour where we demo the UI that we have sitting on top of this to keep. And so when you get into the keep, you get a nice screen that says, hey, create your passcode, which is that first API call. And it uses the top API call to generate random keys for people who want samples to use. And then we do a put against /boot for unlocking. And that's the next nice block in the UI that says, now unlock your key store. Every time you come back into the agent, because you already have a key store, you just have to unlock, right? Because you've already created it. So we're going to try it out here. We called him agent 0. And there's the passcode that we use. And we're going to execute this. And he says agent 0 is now unlocked. And the cool thing about unlocking an agent is you just reload and you now have a whole new set of APIs for doing all the things you would want to do with an agent. And these all marry up very nicely with the CLI commands that we've been running. Get your list of identifiers. Get information about a specific identifier. You can create a new identifier. This would be like KLI incept. You can update. So again, not part of KERI, but to support a user interface, a wallet, for example, where you're going to have a ton of different identifiers, you need to associate metadata with those. You give yourself context to remember, you know, what organization, who. It's just think of a standard contact book.
Right.
That's what this API is for updating that. And because we're zero trust, all that data is signed at rest, so that if you lose control of your database, people can't put in, like, you know, change the name of the contact and fake you out, because we verify the data when we reload it. And then you can do a rotation or an interaction event. This is for creating and listing your credential registries, so the public transaction event logs for anchoring issuance and revocation events. A presentation request. You can generate your own OOBI or resolve other people's OOBIs. This is like the KLI OOBI commands. This is challenge response. So one of the requirements of the keep is that you do a two-factor auth. So this is for generating like a list of challenge words. That's what this guy does, which is just randomly generated challenge words. You would then take those, send them to another person using this command. They would then get a notification that someone has challenged them. They sign it with that identifier and send it back. And now you have proven that they have control of your identifier. And that was actually a big part of the demo that we did during demo hour. This is more information about getting and updating contact information. We also support images. We don't sign those yet. And Sam yelled at me that we have to sign those. He didn't yell, he never yells. And then this is for getting the schema that we loaded via the OOBIs that I showed you at the beginning. This is diagnostics for taking a look at the escrow states. Because all events are asynchronous, passing events around, you can get them out of order. You can get them without full signatures, without full witness receipts. And we have a whole series of escrows that the events just sit in that we constantly check for any other event to come in to resolve them out of their current state. This is for mailbox notifications. So this is a server sent events streaming service for the agent UI to get notifications from the KERI system itself. These are all the APIs for performing multi-sig, and these are APIs for doing credentialing with a multi-sig identifier. And the reason why these have to be different is because there's communication involved. Someone leads the process, that would be with a post, and then others call put to participate in the process. And so, for example, if I have an identifier, if you and I are sharing an identifier where you have a private key and I have a private key, I would initiate it and then send the system would send the credential to you. You would look at the credential, say, yep, this is the one we agreed to issue. You would then do a put with that credential and your signature, and then it would become a valid credential. And we do have scripts and all that can go through that. And maybe you and I can schedule something next week and we can go forward through the multi-sig stuff.
Okay.
All right. So that's most of what I did. We had an hour and a half. So I was at IIW because I did it over the working lunch session, which I didn't get to eat. And we ran through the next set of scripts, which is multi-sig and then multi-sig delegation on both the delegator and the delegatee. And that was fun because you get 4 windows running and they're all waiting for each other. And when you fire off the final one, they all just resolve with signed events everywhere. It's really cool. So maybe we can do that sometime next week.
Okay.